Now, there is a more compact way for you to write down how many subatomic particles you've got inside of an atom. Let's look at an atom. Like, how about lithium? Lithium happens to have 3 protons and 4 neutrons. It doesn't matter where I draw them. This is just showing you how many of each type there are in the nucleus. So that might be a representation of the nucleus for a lithium atom. How many electrons must it have? Well, we learned that every single one of the protons has a +1 charge. So you need to have a -1 charge for every proton. So there'll be 3 electrons because there were 3 protons. And they will be kind of zipping around out here somewhere outside the nucleus. So here's the nucleus and here's the atom outside the nucleus. Now we can write that down a couple of different ways. One way to do it is to write down the symbol of our element. Li is the symbol for lithium. And then up here we're going to put the mass number for the nucleus. So what's the mass number going to be? It is the total number of protons and neutrons that I have in there. So there's 1, 2, 3, 4, 5, 6, 7 different particles in the nucleus. And then down here I put the atomic number. And it's going to be the number of protons. 1, 2, 3. This thing is called a nuclide symbol. Here on the bottom, I put the number of protons. The atomic number is the number of protons. Up here on top, I put the mass number, which is the number of protons and neutrons. So it's protons and neutrons together up on top. If you were to take the difference between these two, that gives you the number of neutrons. So it's not shown directly, the number of neutrons. The number of neutrons is the difference between the mass number and the atomic number. And then I put the symbol of the element over here. So suppose I've got an atom that looks like this. Okay, there's the nucleus. And how many electrons am I going to need? Well, there are 4 protons in there and 4 neutrons. Every proton needs an electron zipping around outside. It doesn't matter where I draw them, or none of that matters. It just matters about the count. So I can tell which element this is if I look at the periodic table. There's only going to be one element that has got 4 protons. That is an atomic number 4. And if I look on the periodic table, it's going to be beryllium, Be. Let's write down a nuclide symbol for this. it's going to have a mass number of what? There's 4 protons and 4 neutrons, so it's got a mass number of 8. Let me get another marker here. And what's its atomic number? That's the number of protons, so it's going to be 4. So here would be the nuclide symbol for this atom. This is one way to show a beryllium atom. This is another way, the nuclide symbol. So it's kind of a shorthand way to show things. Now, here is carbon. This is the most common form of carbon, actually. Now let's figure out how many protons, neutrons, and electrons are in there from the nuclide symbol. So we're going backwards the other way. All right, well, if I look at the atomic number, that's always on the bottom. And you can always tell if you get this wrong. If you get these two swapped, your nuclide symbol always ought to have the bigger number on top. So, if I know the atomic number is 6, that means that there are 6 protons. And since in a neutral atom, the number of electrons has to be the same as the number of protons, I also know from that 6 down there how many electrons there are. Now, how many neutrons? Well, you've got the mass number up here on top, and it's the number of neutrons and the number of protons. And if you take the difference between this one and this one, that gives you the number of neutrons. So you know that there's going to be 12 minus 6 equals 6 neutrons. So I want you to be able to go both ways. If I give you a count on how many protons, electrons, and neutrons you've got, I want you to be able to write down a nuclide symbol. And if you go the other way, from a nuclide symbol, you should be able to count how many neutrons, protons, and electrons. Now, are these two always equal? Sometimes no. What if we had this? Okay. And I put a plus sign there. Now that plus sign is the charge on this whole thing. So this is no longer an atom. It is something called an ion. An ion is something with a charge. And the charge indicates that there's a net positive 1 charge on this. And that means that one of the electrons must be missing. So for this to be sodium, it's got to have 11 protons in it. You can't change the number of protons, or it's not sodium anymore. But you can change the number of electrons, and if there's a missing electron, you'll have a net positive 1 charge. So the atomic number is 11, so you know you have 11 protons. The charge is plus 1, and that means that you must be missing 1 electron. So there are 10 electrons. And how many neutrons? You can take the difference between the mass number and the atomic number. So 23 minus 11 is going to be what? 12, right? So let's do another one that's an ion. How about now this has a charge on it, so this is an ion as well, and that means that the number of electrons and protons are not going to be equal for this, but this time it's a negative charge. So that means that there's an extra electron in there. If there was a minus 2 there, it would mean that there were 2 extra electrons. So when you have a positive charge, it's missing electrons. When you have a negative charge, it's extra electrons. And we don't usually write minus 1. or plus 1 here, they leave the 1 off. So if you just see a plus sign, that really means plus 1, and this really means minus 1. Let's do the counts. Well, first thing I see is that the atomic number is 17, so I have 17 protons. How many electrons? Well, this charge tells me 1 extra electron, so there must be 18 electrons. And how about neutrons? It's going to be 35 minus 17, right? So that'll be like what? 18? Yeah. Okay, see how that works?